Hi, today we will be solving a system of equations in our lesson, but we will employ the graphical method to find the solution to this system. What is the graphical method? You can observe that I have created a coordinate plane. Thus, I will be building something on this plane. If we see a linear equation with two variables, we mentioned that the graph of a linear equation with two variables is simply a line. Therefore, we can draw the graph of the first equation. Next, we will create the graph of the second equation and identify where these equations intersect. The coordinates of this point will serve as the solution to our equation. Therefore, we will identify a point A, which has coordinates x and y. And these values will be the solution to our equation. We state, to solve a system of equations is to find a pair of numbers that satisfies the given condition, or to prove that such a point does not exist. Thus, we will demonstrate that these lines, graphs of our equations, will intersect at some point, and this point will be the solution. But in order to plot the function's graph, we first need to express one variable using the other variable. Let's write the first equation together. X minus y equals -1. We will apply the algorithm for constructing the graph of a linear function. What should we do for this? First of all, to plot the graph, we need to express variable y in terms of variable x. Why? The reason is that a linear function's graph is represented as kx plus b. Or sometimes this equation is written as y equals mx plus b. So we need to show the equation in this format. What do we end up with? We keep y on the left side, resulting in -y equals -1 minus x. We moved x to the right side. Now to graph this function, we need to determine y. But in this case, y is negative, so I will multiply both sides by 1. As a result, y equals -1 times -1, which is 1, and -x times -1, which is positive x. And as a result, we have the equation y equals 1 plus x. In this case, we can plot the graph of this function. To plot the graph of a linear equation with two variables, we only need to choose two values for x and determine the corresponding y values. So we will create a table for x and y. For the variable x, we can choose any value that suits our needs. If x equals 0, then we replace x with 0, and we calculate the value of y. 1 plus 0 is 1. Therefore, when x is 0, y is equal to 1. This is essentially a pair of numbers that solves our equation. We need to solve the entire system, so I will draw a graph. I need more than one point, as I can draw an infinite number of lines. Thus, I will choose another value for x. Value. For example, if x equals 1, then I substitute 1 for x and find the value of y. 1 plus is 2. As a result, I have 2 points. The first point is 0, 1. And the second point is 1, 2. 0, 1, and 1, 2. The first point is 0, 1. The coordinates of the point are 0, 1. Here it is, this point with coordinates 0, 1. The coordinates of the second point are 1, 2. 1, 2. This is the point. and I have 2 points. I will connect these 2 points with a line, joining these 2 points together. Thus, I will have the graph of the function y is equal to 1 plus x. And any point that lies on this line will be a solution to our equation. But we have equations, thus I must draw another graph. Now we have the following equation. 2 times x plus y is equal to 4. Using our algorithm, we will express the variable y. We can write y equals 4 minus 2x. Let's plot the graph of this function. For that, let's create a table and substitute any number for x. It's easy to use 0 as a value. If I replace x with 0, I calculate 4 minus 2 times 0, resulting in 4. Next, we will substitute 3 for x. Now we substitute this value. 4 minus 6 gives us negative 2. I want to emphasize again that you can choose any value for x. Any numbers are acceptable. Choose the ones that are easiest for you to use. As a result, I obtain 2 more points. The first point is at coordinates 0, 4, and the second point is at 3 minus 2. Let's plot these points on the coordinate plane. The first point is at 0 and 4. This is the first point, and the second point is at 3 and 2. Here it is, 3 and negative 2. Now we will connect these points. Thus, we have the graph of the function y equals 4 minus 2x. What do we see? The graphs of these 2 functions intersect at some point. This point represents the solution to our system of equations. We need to determine the coordinates of this point. Here is our point A. With coordinates where x is equal to 1 and y is equal to 2. As a result, the solution to our system will be the point with coordinates 1 and 2. And then this pair of numbers will be the solution to our system. I would like to point out once more that the points I wrote down are auxiliary points that I used to construct the graph of the first equation separately and the graph of the second equation separately. And when the graphs of these functions intersected, I found the coordinates of the intersection point. This pair of numbers, these coordinates, is indeed the solution to our system. Next time we will solve another system graphically. For today, our lesson is finished. Goodbye.